Okay. Ladies and gentlemen, thank you so much for attending our symposium on AI and data science. We have an exciting panel of speakers. Each will give a 10-minute talk, and then we hope to have a discussion, a panel discussion. This is a panel, we are a panel of technology people, and we are dressed accordingly. So we have no jackets on stage. I apologize for that. Or not, I don't really apologize for that, but I still mention it. I hope that you will find this symposium both interesting and instructive. The 21st century is an era of surging, unstoppable change, with so many things, both negative and positive, happening around us at every moment. One of the most significant drivers of these massive, inexorable processes is the technology of artificial intelligence, always coupled with its sister discipline of data science. Essentially, artificial intelligence means that algorithms perform complex functions, previously considered the exclusive domain of human minds. Astoundingly, such algorithms remain as undecipherable as our mind. We know how to develop them, we know how to use them, but we still know very little about how they do what they do. But they do it. Already AI is impacting our lives in numerous ways. Face recognition algorithms, automatic translation, personalized advertising, and there are many more examples. Yet these are only the tip of the iceberg, with so much more waiting for us just around the corner. In upcoming years, we may be able to feed our destination into the computer of an autonomous vehicle and sit back while it takes us wherever we want to go. Possibly by that time, a tiny earbud will automatically translate the words of people we converse with, no matter what language they speak. Robotic physicians will listen to our complaints, examine our condition, and prescribe well-considered treatments, etc. AI-based technology will interact directly with learners also, revolutionizing our learning and teaching practices. These intelligent machines, and many others already in the pipeline, are poised to transform entire professions, altering how we live and how many of us do our jobs. AI also has enormous impact on academic research. First of all, it serves as a novel transformation tool for investigation in practically any discipline, not only in exact sciences, but also the social sciences and humanities, even the arts. At the same time, numerous studies explore AI's growing impact on countless aspects of human existence, from technology through law and society to ethics and philosophy. AI, however, also has its dangers and dark sides. In the wrong hands, AI, big data, and their vast capabilities can spell disaster. Already, the huge amounts of personal information on the internet and social media give corporations disproportionate power over us. Just imagine what will happen if this data and many more will fall into the hands of dark regimes or criminal elements. Tel Aviv University is extensively involved in research on AI, developing its many benefits while looking for ways to counter its downsides. In 2019, we established our new interdisciplinary Center for Artificial Intelligence and Data Science, where we expect to see dozens of researchers addressing challenges in fields as varied as zoology, earth science, Bible studies, anthropology, and many more. We continue to recruit outstanding AI-savvy researchers in various disciplines, and in the next academic year, we plan to launch a special AI studies program for students from non-technological faculties, beginning with the social sciences and life sciences, and gradually expanding the curriculum to include students from other disciplines, including the humanities, law, and arts. At this point, I am proud to present to you the distinguished experts participating in this important symposium. The first to give a talk here will be Professor Yossi Matias, who is the Vice President of Engineering and Research at Google, founding Managing Director of Google Center Israel. He's leading impact-driven research, innovation, and moonshots and advancing AI to benefit society in health, conversational AI, and climate change. He also has many other titles in Google, such as Global Lead of Google's Health AI, Co-Lead of Google's AI for Social Good Initiative, and others. Yossi is the head of the Google R&D Center in Israel. He helped triple Google's site in Bangalore, India, and oversees Google's site in Accra, Ghana. Professor Matias is also a faculty member at the School of Computer Science here at Tel Aviv University. He's a recipient of the 2005 Gödel Prize, an ACM Fellow, and a recipient of the 2019 ACM Kanellakis Theory and Practice Award. Welcome, Professor Matias.
And thanks for inviting me. Can you hear me? Number 7. Yeah. That's the part that I'm saying that we're solving AI, but AV is still difficult. So pleasure to be here. Actually, I remember this hall when I graduated here for my undergraduate degree, so brings back memories. Which is actually a good segue. When I was doing my undergraduate studies here at the university, I was fascinated by machine learning. In fact, my final project was about machine learning, program that could learn to play a game. I used techniques that was actually not very new. It's going back to the 50s, and still in just a few days using old computers. I mean, they were new then. Wrote a program that could actually beat me. That doesn't mean much. I was not a great player in Othello. But still, the real revolution really happened in the last decade, where we have deep learning, which I'm not going to go into, but AI has been since transforming the world, as was just mentioned. So I'm going to touch about some of the opportunities on AI. And before even touching that, if there's one thing to keep in mind is that the growth of AI is not linear, it's exponential. I just had a chat yesterday with one of my brightest engineers and scientists, and we both reflected that what we see today is something that just 3 years ago we could not even imagine. Just 3 years ago, by people working on the forefront of AI. So I'm going to touch on 3 kind of areas. AI is touching all aspects of life. I'm going to touch briefly on 3 areas that are close to my mind. One is about conversational AI, about climate crisis, and about health AI. So let me start with a few words about conversational AI. When talking about conversational AI, it's really about how we can use AI for all aspects of a conversation, anything from a speech, to understand a speech, to speak back, to be able to understand a language, to be able to have a conversation. Now, there are multiple technologies here that, again, if we look into how we're doing today, in fact, up to 30% of search queries by people in India in Hindi are done by people speaking to the phone. The phone just understands them, they get the results on their phone. But we can also now speak in a pretty natural way, which also transforms how we can actually interact with the computer, which is transformative because conversation is the most natural interface for us as human beings. But more than that, the ability to understand the language, actually, if we look into the origin, to the genesis of computer science, the founder of computer science, Alan Turing, kind of coined the question, what we call the imitation game. Can we have a computer actually have a conversation with us in a way that is indistinguishable from a person? And today we're seeing progress that is unparalleled. Let me touch on a few ways in which we can also use conversational AI to transform some of our experiences. So, and again, I'm going to touch very briefly, but a project called Google Duplex is something we worked on and presented 4 years ago, where we showed that one can have an AI bot making calls to make restaurant reservations and have a full natural conversation with a person in a way that is as natural as a person. Now, it turns out that for the last couple of years, this became extremely important because with COVID, businesses in the US actually, their opening hours changed on a day-to-day basis. So we could actually put such a bot into at work, making phone calls and update business information so that people could actually view and know whether a store is open or not, whether there's a mask there or not. In fact, business information based on these kind of calls were resulted with many billions of views that translate into people's experiences. Hold for Me is another example where we can leverage such technology for people calling and getting an answering service. Let the phone wait for them, and when somebody is coming online to have the telephone have a conversation with them so they never need to listen to music again. And Call Screen is about how to never speak with the telemarketing again, because letting the phone to ask who is it, what is it about, etc. Something we can all appreciate. I think it's one of the most popular features that we have today. But beyond that, the fact that we can actually have cross-modality and cross-languages allow us to actually open up content and conversational experience to everybody. So for example, here's an example for a woman in India who cannot understand the text that is out there. She can just point the phone and just hear in Hindi the text that may be written in different languages. And this is actually already working. Or another technology that originated from an idea of an engineer here in Tel Aviv that allows deaf people to have a regular phone conversation just by seeing on the screen whatever is being said by the other speaker, and if needed, also to type back and let the other person just hear it in a very natural voice. So this is an example for, we heard a few personal cases of people that for the first time ever, they could actually have a conversation with a family or just taking care of things. So these are just two examples. Before I move to climate crisis, on conversational AI, I will say that one of the revolutions that we see today is the utilization of what is called pre-trained large models or large language models. We're talking about machine learning models that incorporate billions of parameters, and I'm not going to get into technicalities here, but the utility of those is that today we have AI technology that can understand language in a way that is surprising, in seeing text that was never seen before as is, and putting the inference in a way that we would consider human intelligence only just a couple of years ago, and also can generate text. So this has huge ramifications on many aspects of life, on businesses. Actually, there are many startups based on such technologies. It also brings up many questions around responsible AI, how to develop AI and use it in a responsible way, in an ethical way. Topics such as understanding what AI is doing, which I think we're going to hear about it later today, and about fairness, security, privacy, and many other considerations that are hugely important. Let me jump to the next topic, which is about climate crisis, which we all should care about because it really influences our life, obviously, as we know. So first, from a Google perspective, climate and sustainability has been top of mind. In fact, this is our third decade of climate action. Google has been what we call carbon neutral since 2007, and we made a commitment to be carbon-free energy, namely we're never in any instance not going to produce any carbon by 2030, which is not that far along. Now, in order to do that, there are multiple measures, so let me just give one example for how we can use AI and technology in order to mitigate some of the carbon emission. Turns out sometimes there are various fancy technologies for that. Sometimes it's just about how to handle our life in a more effective way. Turns out that a lot of the carbon is actually emitted while cars are waiting in intersections, and just by using AI for better optimization of the traffic light, something that we've been doing in a pilot in a few places in Israel, Rio, and other places in the world, you can actually reduce up to 20% of the wait time of intersection, which has huge ramification of how much carbon is emitted, of course, in addition to the fact that it's a little less frustrating to sit in that traffic light. So this is one example of how we could use AI for carbon, for less carbon emission. Let me also touch on another aspect of climate crisis, which is the adaptation. So with climate crisis, we have many more fires, we have many more floods. In fact, this is a picture I took 10 years ago during the fire in the Carmel Mountain near Haifa. I was there, and we also have an office in Haifa. And I was actually looking for information. This was actually a trigger for a long-term effort that we call crisis response. As part of that, recently we enabled using satellite imagery analysis in order to be able to provide in near real time an update on every hour the perimeter of the fire and information that is hugely important for people to keep safe. When talking about climate, it turns out that, or about natural disasters, the most significant one that we know of are floods, which kill thousands of people per year. And it turns out that with AI technology, we can actually make predictions about where floods are going to be. In fact, just in the last monsoon season, we sent over 115 million notifications to people at risk in India and Bangladesh, alerting them about floods coming their way. And just in 1 minute about health. So health is one of the areas where AI is going to, in my mind, have one of the biggest transformative impact. In multiple ways on how people get information, how we're actually using our devices. Our phone can actually become actually a health device, in how to improve the operation of many people. So just to touch on one example, which is close to home. Here's about a project that actually we have a team in Israel working with Shaarei Tzedek and about improving, reducing the number of misses in colonoscopy, which is shockingly up to 20%. Turns out that with AI, during real time, we can actually help doctors to reduce that quite significantly and save lives. So this is one out of many examples about how we could use AI and using AI screening, for example, in Thailand and India to help save people's sights. And all of that is enabled by a combination of scientific research, of advancing, of putting technologies together, of working in tandem with academia, with industry, with governments. I think that the opportunity for AI to have a player in societal change is enormous. In fact, we have a joint collaboration with Tel Aviv University about a program on AI for social good, which is in the context of the AI Center here. And I think it can actually also transform a lot of the research that we're doing, because AI is becoming a vehicle and a tool, a lever to actually transform the work of any discipline, academic and scientific discipline, as well as leverage for each of them. And with that, thank you, and looking forward for many more opportunities in AI.
Thank you, Professor Matias. Our next speaker is Dr. Dorit Ron.
No.
Sorry, Dorit Dor. Dorit is the Chief Product Officer at Checkpoint Software and a Tel Aviv University alumna. She's one of the world's leading women in cyber. She has been serving as Chief Product Officer at Checkpoint Software Technologies for more than 25 years, leading an organization of over 1,500 employees and managing all of Checkpoint's products, research, and development. Dr. Dor is a prominent speaker on cybersecurity and a frequent keynote speaker in some of the world's biggest cybersecurity and technology conferences. She was named one of Israel's most influential women by Forbes Israel. She's a member of the World Economic Forum and of the Global Future Councils.
Thank you.
Please.
Thank you very much. Thank you very much. So thank you for the introduction. Indeed, I'm a proud alumni of Tel Aviv University. I did my bachelor degree and all the way to PhD in computer science. That was many years ago. After that, I joined Checkpoint. For the purpose of cyber, I was also quite a few years in 8200, which is known as a unit that has some cyber effort. And I used to be a frequent flyer before all this COVID stuff. I'm still hoping to get back to flying anytime soon. And today, I'll talk about cyber and AI. And before that, I'll introduce kind of my background, as I'm very much associated with Checkpoint. Checkpoint is a cyber leading company, traded in the NASDAQ since '96. We have over 6,000 employees. I manage over 1,600 employees, and we are proud of doing innovation in the cyberspace. So here is my attention to computer science alongside with some attention to cyber. By the way, if someone wants to keep me on 10 minutes, then you should put the time up. But I'm okay to speak for as long as you want. So let's start with kind of the basics. The AI, what does it do, AI, for us? If we took the Industrial Revolution, it took some muscles and tried to use machines instead of muscles, and with the AI, we try to use machines instead of brain. Well, we don't really instead, maybe in addition, but we will discuss this. And why is it now? What's relevancy for these days? Why are we so excited? Today, there is a collaboration of many aspects that came together to make the AI more prominent. The fact that we have a lot of data, we could store data, we could manipulate data. The fact that we have very scalable, high-end, and very strong and evolving compute, and the theoretical part of math that make it very appealing to use the compute with the data and to make something reasonable. But I'm not here to talk about AI, I'm here to talk about cyber. So let's start to understand why is AI a good tool for cyber. So point number one is that cyber is all the time evolving. If I gave you a very static algorithm, it may fit something that happens today, but the event of tomorrow would not be maybe addressed. The AI have the same type of self-evolution that the cyber has, and so by using AI, you could adopt your algorithms over time. The second part is that attack stands out in different ways. There is something about the attacker that behave very differently than the norm, and AI is good in kind of identifying such anomalous bad stuff. The third element is about scale and fast. Attacks tend to come very, very fast and at scale. If you have already a very strong tool, weapon at your hand, you'll try to use it as fast as you can. And with AI and all the compute, we could do it very fast. We are short in expertise. That's true for other spaces, but that's true for cyber as well, so it could help. And last is the world is connected. If in the past it was hard to get data, today, in the cyber, we have a lot of data, and I'll talk about it soon. So to understand our kind of approach to market, we come to help customer conduct their business on the internet in the highest level of security. And when we mean security, we mean to stop the attacks. And that has some implication on what types of cyber applications I would be looking at. So at the left side, it's kind of the defense against attacks. Here I want to identify something as malware, identify source injection, identify that your email is phishing, identify that a bad behavior is part of an attack, or identify that a sequence of things is more likely to happen as part of the attack than it is likely to happen on a normal basis. On the right-hand side, there are many other things to do with AI that relates to cyber. For example, efficiency, automation, configure your system to be more secure, replace the analyst. These are more conventional applications of AI because they are more similar to the other world. I'm deliberately talking about the left side because I think it has some interesting aspect. And last but not least, we're not doing offense, but some AI is being used for offense today, so kind of let's find the best malware that will attack your system the best. This is not going to be the topic of today. So because coming from Checkpoint and that our mission is prevention and not detection, we're trying to get very accurate verdict so that we could do practical prevention. Because we need to stop the attack in real time. This is a challenge. And for that, we need the verdict to be very accurate. Why is it a bit challenging with AI? One of the reasons that it's challenging is that it's kind of a probabilistic by nature. We used to use more deterministic methods to know that something is bad. I think that deterministic methods are limited anyway, and so AI and probabilistic methods needed anyway, but it's a bit harder to get an accurate verdict. And the second part is that the other side that I gave the verdict to should understand that I blocked a bad attack. So the customer has to understand that I indeed blocked an attack, and they don't always trust the AI. So the AI needs to explain itself, and maybe Lior after me would explain how could AI explain itself better. The cyber and the AI come together Like many other things, it requires data and analysis. It requires lots of data. It requires rich data from different sources, different types. It requires AI expertise, and it requires cyber expertise. So to build up a cyber AI operation, you need both. One of the challenges is that there isn't so much data. So there is a lot of data about normal operation, but there isn't so much data about diversified attacks that we could really label, understand, and learn. We may have lots of data on the same attack, or we may have lots of data on normal operation. But it's really not that easy to find the data that we need, and it's also very hard to combine the expertise that we need. We take these together. We have like 86 billion calls a day to something we call threat cloud, which I would not explain. And we try to make cyber applications. So I'll give 4 out of which I'll really speak about 3 applications of cyber in terms of stopping attacks. The first one I'm really proud at. There was a few months ago an introduction of a new vulnerability in open source application called Log4j. This is a normal open source application used by many people that had a bug inside. Apparently, the bug could be used to form an attack, and since there were millions and millions of users of this code around the world, because it was open source and widely used, attackers could very easily use it. This goes to the problem of cyber. At very high scale, very fast, all these attacks are coming. And our mission was to stop the attack preemptively. So without knowing that the attack will ever occur, we used AI and we stopped the attack. We did it by identifying that this behavior is suspicious and then using AI to understand that it's indeed suspicious versus the normal. So if you were a customer and you were using web application and API protection from Checkpoint, we were stopping an attack that we never knew about. The second example I'll use is malware DNA. We take the DNA, we kind of classify it into malware. It's a bit similar to if you want medical operation, etc. You do it by code analysis, by behavior analysis. A cool story, an NSA group named by Equation had compiled some malware in 2013. In 2016, it was stolen by a shadow broker, and in 2017, Windows protected against this attack. We apparently, just for a research, took some Chinese malware that we found, analyzed its DNA, and learned that it's actually based on the Equation malware from 2014, meaning that the Chinese had the Equation malware before it was leaked with Shadow Broker. And interesting things that you could learn from analyzing with AI. The third example is phishing. You all get these emails, you know, press here, you will get a prize, or here is your mail, and we just need your password here to arrange something. And we need to identify a good from bad. We need to identify good websites from bad, good emails from bad. We need to understand the context of the email. We need to understand the reputation, the icons, etc. The fourth element I won't even explain. We use domain names in order to operate our malwares in the world. A very strong usage of AI is to identify that a domain is related to the bad guys and do all kinds of things about it. If you want, that's for a different lecture. This is a teaser. 4 things I'd say that I learned that are kind of challenging in this space. One is commercial. It's very easy to claim we have AI. It's very hard to prove that it actually does something useful. Second challenge is privacy. We collect a lot of data. How do we keep the privacy of the data we collect? That's true for any AI. Third is every new topic have a new problem, especially in cyber. So with the new topic of AI came the topic of AI war between the good AI and the bad AI, something to be discussed. And the fourth thing is that identifying the bad guys has the context of understanding the justification, the good, the reasoning, the context, and it's not very easy to do with AI. Last sentence, There are other operational related issues with AI, like how to operate the AI within a large R&D organization, and that remains a challenge for the future. So I truly believe that we could use AI to do the best security, but there are lots of challenges, and that's good.
Thank you, Dr. Dor. Our next speaker is Professor Lior Wolf. He's a professor at the School of Computer Science here at Tel Aviv University. He has had many notable scientific accomplishments, including ERC grant, Best Paper Awards at prestigious conferences on computer science. He was also awarded the ICCV 2001 MAR Prize Honorable Mention. His research focuses on computer vision and deep learning and includes topics such as face identification, bioinformatics, medical imaging, document analysis, voice generation, and whatnot. Please.
Thank you very much. So this is number 3. I don't think it's working. Is it?
Yes.
Okay, good. Thank you.
You just have to hold it close to your mouth, I suppose.
I think it started to work. No? Okay. So thank you very much. It's an honor to be here. I don't want to go into too many technical details. I'll try to have some nice demonstrations and maybe engage the audience a little bit. So, I'm heading for many years now the Deep Learning Lab at Tel Aviv University, which is not only the first deep learning lab in Israel, it's also the largest lab in Tel Aviv University with regards to the number of students. So we have many, many students, each working on a different topic. And just to give you an example of the various projects that are going on, so we started in computer vision, and we have many achievements in this. For example, real-time semantic segmentation. Whenever you have an image, you want to analyze what's in every region of the image. And in a completely different domain, we are working on engineering tasks, for example, designing antennas for mobile phones using deep learning. Using a different type of technology, we try to get into quantum computing and optimize quantum computing hardware. Again, using deep learning. Deep learning and AI are very diverse technologies. In cyber, we have been working on some attacks. This is not on the defense side, this is on the attack side. But understanding the attacks actually help us avoid these scenarios. And we have many collaborations around campus with medicine, humanities, biology, and so on. This is an example with Thelma Handler about analyzing fMRI in order to better treat PTSD. So I came to speak about Explainable AI, and there's so much that I can tell you about it, but trying to keep the conversation non-technical, I decided that I will not speak, for example, about the societal need, because the former speakers spoke enough about the dangers and why we need to understand and fairness and so on. I just want to give you some examples of a very specific system, and how we use it to interpret AI in a way that is very accessible. You don't need any technical background in order to understand this. So I will start by a few technical slides, and then I will move on. So there's currently a revolution in AI. And the revolution, and Yossi was talking about it, is that of very large models. And the nice thing about these models is this, that once you train these models, you can perform many other tasks with these models. So specifically, we're talking about something that is called zero-shot learning. Zero-shot learning means that we have this huge model, and we can then use it in order to do new tasks without retraining it. So in computer vision, what really made the revolution is the model named CLIP. This is by a company called OpenAI, which used technology that was developed first in Google in order to solve the following task. We have images, we have sentences. We want to know if the image and the sentence describe the same scene. So is the sentence in text the correct caption for the image? So you can see here maybe the font is a little bit too small. It's about a dog called Pepper, and you see the image of Pepper. And you give the machine many images and many captions. And the machine during training needs to find out which sentence matches which image. And this is trained on millions of images, millions of pairs of caption and images. And once you have this trend, you have a very powerful model, and you can use it to perform many other tasks. The simplest of these tasks is object recognition. I want to know what's inside in the image in the bottom left. So I give it all sorts of sentences. This is an image of a dog, this is an image of a house, this is an image of a car, and so on. And then I let the machine pick the correct sentence. So what I just told you is what the smartest engineers in Google, Facebook, OpenAI, all these companies are doing, basically trying to use a pre-trained model and get it to work on new tasks by performing these type of tricks. So here you see a very simple technique, just generate many different answers, select the best answer, and it's highly effective. It's as effective as teaching the machine to perform the underlying task itself. So given the importance of these models, we ask ourselves, how can we look inside these models? This is just one form of explainability, but we want to understand the thought process that is going on within these models. So what we did in order to achieve this is to take this model, this CLIP model, and to marry it together with a large language model. So exactly the same type of language models that Yossi described for conversational AI. We want to look inside the brain of the computer vision model and see what's the thought process. Basically make it speak in words. So a language model is a model that generates a sentence. Just like in my brain, I'm always thinking about the next word and the next word and so on. Same goes with the language model. So it starts to generate one word after the other. It says image of a bold, and then the next word is probably going to be an eagle because this is what's inside the image. And once we did this, we were able to look at images, and then the computer generates sentences. So this is kind of a dream of computer vision. Give me an image, I will generate a sentence. This is called captioning. We let the computer describe the sentence. What's really nice, if you look at the bottom result, this is our result, which is not trained. This is zero shot. We take the vision model, we take the language model, we combine them without training, and we get sentences that are much more descriptive and much more specific than the sentences that are generated by captioning methods that are trained. By skipping the phase of training, by letting AI tell us what it knows, we're able to extract much more meaning from the images. So we can discover very easily that what you see on the top is the image, on the bottom is the generated caption. You can see that the AI has a lot of real-world information that is encoded inside. We don't need too much. Basically, it tells us, it generates a sentence, and this is what you see. So it can recognize Barack Obama, Donald Trump, The Simpsons, and so on. In comparison to captioning system, it's very chatty. We can get a lot of information out of it. It likes to talk a lot and gives us full description of what's going on. And you can see it in all of these examples. Sometimes what it's saying doesn't really match the image perfectly, but it always makes sense and describes elements in the images. We didn't teach it to read. We actually didn't teach it anything, but it turns out that it can read by itself. So if you give him this image, he knows that this is a birthday cake for a kid named Sean. We didn't teach it OCR, how to read, just learned by itself. And using this technology, we can see that indeed this information is captured inside. And let me give you one more example that would help us understand the way that these kind of models are working. So this is about visual arithmetics. Instead of giving one image, we give an equation of images. And we ask, solve this equation, generate a sentence that describes this equation. So I know you see it for the first time, so it's not so obvious what you see in this equation. So let's go over the equation step by step. So you take a king, you subtract a man. What do you get? You get royalty. You add royalty to this young woman. What do you get? A young queen. So what you see on the right is the sentence generated by the machine given the equation on the left. And let's look at another example. This example, I will let you think about it for 24 seconds. Anyone has a guess what it means? So you take an egg, you subtract a chicken, you get something like a food by an animal, you add a cow and you get milk. A cow's milk. And it's actually very smart. We're not giving any hints what's going on. The computer generates the text by itself given an equation. So if it's a caricature of an airplane minus an airplane, the answer is just a caricature. And if we look at a skateboard event, we subtract the skateboard, we get the event as the answer. And if we have many basketballs, and we subtract one single basketball, then we get many. Many is the answer. So I'm out of time, but this is entirely convincing. And what's fun, you can do type of analogies. I won't go into the equations, but you can basically solve things like a pizza is for Italy as a baguette for which country, and the computer basically generates the correct answer by combining text and images together, and we can really see the way that the wheels are turning inside of the machine. So I can tell you more about how to do science, and I think Yossi and Dorit both touched about it with AI, but let's leave this for another time. Thank you very much.
Thank you. Thank you, Professor Wolf. Our last speaker today is Ms. Merav Noy. She's a different generation. She's a master's student here at the Blavatnik School of Computer Science at Tel Aviv University. She specializes in bioinformatics and works under the supervision of Professor Ron Shamir. Omer holds a combined bachelor's degree in computer science and psychology with an emphasis on neuroscience, also here from Tel Aviv University. And her research now focuses on applying machine learning and novel algorithms to healthcare, especially in terms of providing decision support tools for clinicians. She's a recipient of the 2022 Celia and Marcus Maus Prize for Master Students in Computer Science. Please.
Thank you very much. Thank you for the introduction, and thank you for the organizers for inviting me to speak today. Can you hear me right? So my name is Omer. I'm a researcher here at Tel Aviv University, and I've been studying here for several years, starting from my first degree, in which I studied in a special program combining computer science, neuroscience, and psychology. And actually, this program gave me the first opportunity to get a taste of research in the field of AI and healthcare, and it gave me inspiration going forward. Then, after a short period of working as a software engineer at a high-tech company, I decided to come back to the university in favor of research, and I started my master's degree under the supervision of Professor Ron Shamir, and now I'm about to start my PhD here. So I'm really passionate about the field of AI and healthcare, and this is my primary area of research. And today I would like to give you a taste of how we used AI at the beginning of the pandemic. Thanks. All right. So here is a view of the pandemic in Israel until July 2021. Presenting daily cases across time using weekly averages. And you can also see our first 3 waves. Of course, since then, we experienced additional waves with different disease characteristics, but most of the story of today is about this period in red, during the first 2 waves and during full lockdowns. So as the first cases were confirmed in Israel, we gathered together with our clinical partners from the Tel Aviv Sourasky Medical Center, and we were thinking about how we could help and how we could contribute to this situation. So we decided to provide a decision support tools to clinicians, and we tried to understand the clinical need as we go. At that point, there was already evidence that early treatment may prevent clinical deterioration of COVID patients. So we decided to focus on that problem, and we tried to develop a decision support tools to clinicians for predicting who is likely to deteriorate among hospitalized patients. And we believe that we used AI to develop this model, and we believe that such a model has the potential to improve patient care, for example, by preventing condition worsening, and that it also has a potential to improve resource utilization at the world level. So to train an AI model to learn the differences between patients who are likely to deteriorate or not, we have to use real-world examples from hospitals' data sets. So we leverage our existing collaboration with the Tel Aviv Sourasky Medical Center, and we initiated additional collaboration with the Sheba Medical Center, thus collaborating with the 2 largest hospitals in Israel. And we use the patient-specific data that is available through the electronic medical record systems. So this data contains various types of health data, including demographics, medical history and medication, vital signs, habits, and lab tests. And this high dimensionality of this data enable us to capture the specific medical condition of each patient across time. So we developed a machine learning model that predicts for each patient whether he or she will deteriorate within 30 hours. And it generates a new prediction every hour during the hospitalization using all the data collected so far. So if a deterioration is predicted within 30 hours, it will raise an alarm at least 7 hours in advance. So we have enough time to change a therapy strategy if needed. Okay, so we developed this model throughout a multi-stage process, and we try to account for multiple clinical and technical challenges. And in fact, our clinical partners and domain experts were an integral part of this process, and we always try to stay connected to the clinical intuition. Now, once we developed our model, we can then test it on new patients that were not used for model development. So at that point, we want to know how our model is working and how well it's predicting what we're trying to find out. So we usually monitor performance metrics such as sensitivity, specificity, and positive predictive value. So in our case, when used for new patients, our model identified 44% of the positive cases, as well as 97% of the negative cases where no deterioration events occurred. And 87% of the cases where our model raised an alarm were real cases of deterioration events. So there is also, in addition to the technical challenge of model development, there is also a clinical challenge. When thinking about the integration and deployment of such models into hospital system, a main consideration is alert fatigue. So there is always a trade-off. On one hand, we don't want to turn off certain alerts because we don't want to miss deterioration events. But on the other hand, having too many alerts firing, it's also dangerous because many of them could be ignored. So in model development, we can select the decision threshold that balances this trade-off between specificity to sensitivity. So for example, we could increase the model specificity, having fewer false alarms to mitigate this alert fatigue, but with the cost of detecting fewer deterioration events, and vice versa. So this is an important consideration that one has to take when thinking about deployment. We also used a method called CHAP values from game theory to reveal the most important clinical parameters for deterioration prediction. So consistently with previous study, we confirmed the importance of known medical markers such as age, body temperature, and oxygen saturation. And I will just finish by mentioning that since then we extended this work and we conducted broader analysis, accounting for additional outcomes, for new challenges, and by utilizing larger data sets from additional hospitals. And this was just an example to show you how we used AI for COVID, but we are developing in our lab various of tools to a range of disease, including other infectious disease, metabolic disorders, and cancer, always with the ultimate goal of improving patient care. Thank you.
Thank you, Omer. Thank you. So we have a little time left, and I would like to start a discussion on one topic. We've all heard you talk about what's going on with AI today, your predictions about the near future, things that are in development today. And on the other hand, we've been hearing about research that showed that machines make better decisions than judges in some cases, or that machine physicians, robot physicians, work better than human doctors, and so on and so forth. And I would like you to comment on that. When is this going to change our life in a significant manner? And what are the things that, if there are such things, that will never be done by machines better than they are done by humans? What are the limits of artificial intelligence? Let's start with Yossi, maybe. It was the first speaker.
Yeah, so again, I think that, let me quote, I think it was Bohr who said, prediction is hard, especially about the future. But we can safely predict that we cannot predict how it's going to evolve. As I mentioned, I remember when we saw the first self-driving cars in California, this was kind of science fiction. And today, actually, every company has it, and obviously we have a great presence in Israel. As I mentioned, some of the technologies that we see today were not imagined just a couple of years ago. So if you try to do a little bit fast forward, 5 years, 10 years, it's practically impossible. We should assume what we do see is that there are many barriers that we thought are limitations. Creativity, reasoning, inference, the examples that Lior gave, they're all kind of overcome more and more and more. I'm an optimist. So first, I think that these are amazing technologies that we can actually solve problems for people. We can leverage on them if done properly, and we should, as a society, address them properly. And it's going to shift a lot of our thinking on many of the areas. You know, I just read this about just a few years ago, people thought that AI is going to address, or technology is going to replace the monotonic things. But what we see now is that they can write text, they can do some creative copies, they can bring images together, they can, even write some music. And so again, is this going to replace musicians or creators? Of course not. It's going to, in my mind, up-level the level of what is creativity for the human creativity.
Why not? Why not replace musicians and physicians and...
Well, they're going to do part of the work. So they're going to, again, I remember speaking with a university a few years ago, and he told me that in medical school they are changing some of the radiology reading classes with AI understanding because you can actually do more. Now, if you go back, there are many things that we used to do, and then we started using tools to do them, and don't look back. So somebody was asking me once, am I concerned about the fact that my kids cannot navigate? And I said, I do, but you know what? I'm sure some people are concerned that I can't really operate a carriage with a horse, and that's fine. So I think that our level of operation, human operation, is just going to be increasing, and we're just going to use tools. Now, it's not linear because it's transformative. The tools that we're using are a different level. And again, talking about doctors, we're going to solve problems in a way that we couldn't do before, and increasingly so.
The same way that, I don't know if you hear me?
No. Well, why don't
Okay.
you
The
take
same
mic?
way that, okay. So let's do with this. Now you will hear me twice. In the same way, we could ask if it will replace the musicians, we could ask if it will replace the listeners. So we could send our AI to listen to the musicianer AI. I just felt it's obvious to say this. But I think some of it, today, it's used like an algorithm or a tool. And some of the question is, will it be the whole, right? So for it to be the whole, the AI needs to handle also the things that we handle now for the AI. For example, we collect the data, we give it to the AI. We label the data, we find what's ground truth. In order for the AI to kind of replace the whole, it has to do all of that. So it's very easy to predict that it would be an even stronger tool, that every physician would have to consult an AI, and that you would want the opinion of that, and that many applications it would be true. But the question, will that become the whole? I don't know.
You don't know, but you don't know that it will not.
I can never say that it won't, but it's more complicated answer. You have to find where the data in the world is, what type of data you want to collect, what do the user want. It's kind of, you have to replace the whole ecosystem. As a doctor, you need to know what the client wants to hear. It's about the interaction. It's not just about the diagnostic. So to move it from like the tool that does now the diagnostic for this scenario based on this data to becoming kind of the whole profession, it's a bit of a jump.
It's interesting that computers can do all the complicated things, but collecting data we still need to do for the computer.
No, it's not really that we collect, but we need to kind of tell it what to collect, in a sense.
Lior, what is your opinion on this?
So I think that my friends here have been overly conservative, and I can understand why. Yossi is a very senior person in a very important company, and Dorit as well, and they really want to be conservative, but there isn't any roadblock for AI to be the best musician in the world, or to be the best novel writer, or the best lawyer, or anything else. And this would come and would arrive already driving better than humans, already proofreading very efficiently, creating very convincing text. So there are no roadblocks for this. I think the next revolution is going to be in grounding the AI in the real world, providing actual robotic arms, robots that go around, that can perform tasks in the real world instead of humans. This is going to be the next challenge. But everything that has to do with the data and sits inside of a computer and is about processing data or creating, this is something that computers are going to be able to do better than humans in the very, very near future.
Omer, as the youngest person in this panel, are you ready to live in a world like this, like Lior has just described?
So I can't imagine how it will be like in 20 or 30 years, but I think that in the field of healthcare specifically, I can't imagine that the AI tools and models will replace the clinicians or the caregivers. I see the future as a combination of the models with the caregivers trying to fit the best solution for each patient, but I can't see it only as AI.
Well, go ahead.
I think there are two parallel questions, one about skills and the ability to address certain things, and the other one's about societal questions. So one observation is that just a few weeks ago, or a few months ago, everybody thought that the world is going to be different. We're actually not going to fly and meet together and sit in this conference. Why would we do that? It's all online. We figured it out. And what I see again and again is that we're back. There are certain things which are very human behaviors that are not that different. And actually reflecting, we had this project of bringing online the Dead Sea Scrolls 2,000 years ago. And when you think about it and you look into the language and thinking about the society then, there are certain characteristics which are not different. in terms of what you do and how you do, yes, there are certain things today that are going to be done by technology, but if you look back, we already have, I mean, if you go to check your eyesight with a machine, a lot of that is now done automatically. Just a few years ago, this was a highly crafted discipline. So we're going to see more of that, but there are certain things that are actually not going to change that as much as we thought they would be.
Okay. So computers will still need us, you're saying?
We will still need us. Computers are self-sufficient.
Thank you very much. How are we doing on time? I thought that... This is it. Okay, so thank you. Let me thank the audience again. And let's hope for a nice future, a good future with AI. Thank you.
Thank you very much.
Thank you.